Good afternoon, science students. We're ready to do guided notes for page 11 through 14, explaining the circulation of air. Starting on page 11, at the top above the two kids with the balloon. The effects of Earth's rotation. How does wind feel as it blows across your face? Wind is made up of moving particles. Even though you cannot see these particles, they are matter. You also cannot feel or see the movement of the Earth. Our planet spins on its axis as it moves through the solar system. This movement has an effect on matter in the Earth's atmosphere. Okay, we're going to skip the demonstration, and you have two things to fill in from page 11. When done, turn to page 12. Okay, the second important point in this lesson is wind and the Coriolis effect. Very important. Biggest thing of this whole chapter is being able to tell me what Coriolis effect is. Wind moves from an area of high pressure to an area of low pressure. Wind on a large scale moves across the Earth because our planet has high and low pressure bands. High pressure bands form near the Earth's poles, North Pole and South Pole. As the equator gets more solar energy or sun energy than the poles, low pressure bands form above the equator. The band has convection cells between them. So high pressure bands near the poles, low pressure bands near the equator. And you can see this as we're talking through on page 12 in the pictures to the right of the reading. Cool air is denser than warm air is. If no other factors influence the flow of air in the atmosphere, air at the poles would sink and flow toward the equator, pushing warmer surface air ahead of it. At the equator, the warm air would rise and flow towards the poles, cooling as it moved. Then the cooled air would sink at the poles. As a result, Earth would have two large convection cells. One would extend from the North Pole to the equator, and the other extends from the South Pole to the equator. Within these convection cells, air would flow in a straight line as it moves between the poles and the equator. However, the air in the Earth's atmosphere does not move in such a simple pattern. One reason for this is that the Earth rotates on its axis. Okay, so if you look at your page, you are going to fill in this area here under number 2, and then continue down. Okay. And then now we're going on to the checkpoint question. How does the rotation of the Earth affect the wind? Rotation of the Earth affects wind by flowing in what kind of path? Okay. So which kind of path does it follow? Okay, we're going to move from the spinning of the Earth on its axis causes a similar deflection of the Earth's winds. This effect of Earth's rotation on the axis of the winds is called what? I think we just defined it. As the Earth spins, wind in both hemispheres curve. 2 checkpoint questions, very simple. Tell me which way the winds curve in the northern hemisphere and which way they do in the south. Now we're going to move on to formation of wind belts. which is on page 13. Page 13, and I'll just type that in right now so we have that. All right. The Coriolis effect prevents wind from flowing directly from the poles to the equator. The curving horizontal winds combine with vertically moving air to form smaller convection cells that are about 30 degrees of latitude wide. So these are smaller convection cells within the bigger northern hemisphere and the southern hemisphere. Bands of high pressure and bands of low pressure form between convection cells as shown in the diagram. Look at the diagram at the top of 13. Cooler, denser air sinks along the bands of high pressure. Warmer, less dense air rises along the bands of low pressure. This pattern of vertically moving air, curving horizontal winds, and the bands of high and low pressure form 3 wind belts in each hemisphere, which you will see the wind belts at the bottom of 13. Okay, so moving right on down, formation of wind belts, kind of just talked about that. We're in our last section, global winds, which is still on page 13. Global winds. The sun's rays hit parts of the earth at different angles. Because of this, the sun warms the earth's surface and the atmosphere more at the equator than it does in any other place on the earth. This unequal heating of the Earth's surface and the Coriolis effect causes distinct patterns of global winds. These wind patterns blow in fairly consistent, steady directions across Earth. Each global wind pattern has a specific name. So please look at the model right now, and in your notes, I just listed them. But find out where they are located. There's some in the northern hemisphere and some in the southern hemisphere. The equator is known as the doldrums because the winds are kind of flat because of the heating. They don't have as much variation in their heating. Okay, you can read on each of these winds. In the northern hemisphere, you have polar easterlies, you have the westerlies, the horse latitudes, northeast trade winds. And then in the southern hemisphere, you have the southeast trade winds, horse latitudes, westerlies, and the polar easterlies. Okay, very similar to what you have in the northern hemisphere. Okay, if you notice, westerly, horse. Okay, you have the polar easterlies on both ends. So they are fairly consistent and listed. That's it for your notes today. Please fill in the spaces that were left, and you'll be watching some videos on the Coriolis effect, which should help you with your understanding. All right, have a good rest of your day.